Hello, Algebra 3. You should have in front of you Day 4 notes for Chapter 4. And this is where we're going to look at our last exponent property, which is fractional exponents. And then what does that mean for when we rationalize the denominator? Okay, so again, I want you guys to think about what something means before we just jump into doing problems. So let's go back to what this means. 9 squared means you have 9 times 9, which is 81. And we can always work backwards. So when we were working backwards, remember to undo a power, you take a root. So the square root of 81 is 9 or negative 9. So we know that these things called powers and roots are connected, and we know that they undo each other when we're looking at these problems, okay? So, but let's ask this next question, is what happens if I have some number or something raised to a fractional power? Okay, meaning what happens if I have 9 raised to the 1/2 power? I think I'm going to try to bring this up just a little bit more, guys, just like that. Okay, so let's take a look at what that means. What happens if I have 9 to the 1/2 power times 9 to the 1/2 power? Well, remember our exponent properties mean we're going to add those exponents. So I get 9 to the 1/2 plus 1/2, which just gives us 9 to the first power, which is 9. So I want you to think about that. 9 to the 1/2 plus times 9 to the 1/2 is just 9. All right, so let's look at this one. The square root of 9 is, we know it'll be plus or minus 3. For right now, I'm just going to use 3. So the square root of 9 times the square root of 9, or sorry, the square root of 9 is 3, so I have 3 times 3 is 9. All right, I hope you see a pattern there. Both of my answers gave me 9. So let's think about this. 9 to the 1/2 power, 9 to the 1/2 power is the same thing as the square root of 9. Okay, so let's think about what is 4 to the 3rd power. Well, that's 4 times 4 times 4, which gives me 64. Well, then I can undo that. Remember, I can always say, if I raise something to the 3rd power, I can undo that with a cube root. So the cube root of 64 is 4. So what does this all mean? Let's put all of this together. Roots and powers can all be connected now. If I gave you 64 to the 1/3 power, what it is I'm asking you is I'm asking what number times itself 3 times gives you 64. So this really means this is the cube root of 64. So a fractional, so think about this, guys, a fractional exponent means you are taking the root of something. Oh, now this is going to get kind of interesting. So we're going to take some number, we don't know what it is, x, and we're going to raise it to some fractional exponent. The numerator is going to be the power. What are we going to raise it to? What's the power? Well, in this example, okay, we took it to the 1st power, but we then look at the denominator, and the denominator is now the root. Okay, and you can see that. Here's the root. What is the root of that number? And then raised to some power. Okay, that's what that looks like. All right, it always helps when you see something like this. It always helps to see an example. So let's try this example. Okay, I have 216 raised to the 4th, okay? I'm going to color code this so that we see what is what. So I see that I have 216 raised to the 4/3 power. Well, what does this mean? Well, it means I have 216, and I'm going to take the cube root of it, and then I'm going to raise it to the 4th power. Okay, take a minute to think about that. I'm going to cube root it, then take it to the 4th power. That's what a fractional exponent does. Okay, so let's take a look at what's inside parentheses. The cube root of 216 is 6. And now I'm going to take 6 to the 4th power, which is 1,296. Okay. All right, let's try another example. Okay, I have 64 to the 2/3 power. All right, sometimes you have to color code this. I'm going to take it to the 3rd root, and then I'm going to square it. All right, so when we look at this, I'm going to have the cube root of 64, and then I'm going to square it. That's what that looks like, and then you do just what's in parentheses. So the cube root of 64 is 4, and then I square it. All right, last one that we're going to try together. So remember, fractional exponents give us a root and a power. All right, this last one might seem intimidating, but it's really not. You just have to remember what your exponents, all of our exponent properties don't disappear, okay? It means that we have to do these same things. Don't worry about that it's negative 1/3. So, power to a power. Everything has to be raised to the negative 1/3 power. So I have 27 to the negative 1/3 power, and I have 125 raised to the negative 1/3 power. All right, well, what does a negative exponent give me? Well, a negative exponent means it's in the wrong place. So then, this 125 to the 1/3 power needs to move to the numerator. The 27 to the negative 1/3 power means they need to move to the denominator. That has not changed since our very first video of exponent properties. It's just now that our properties have fractions with them, but that doesn't change anything. Okay, so now I can really think about what does that 1/3 power mean? Well, it means I'm taking the cube root of 125. Now we're also raising it to the 1 power, but we don't really write that. And then we're going to take the cube root of 27. All right, so remember the cube root is asking what number times itself 3 times gives you 125? Well, that's 5. The cube root of 27 is 3. And our answer then is 5/3. You're going to get a lot of these on your daily practice. Try them on that homework. You're going to get good at these, but remember, fractions, fractional exponents means roots. All right, one last thing that we're going to do with our properties of exponents and roots are going to be, can you rationalize the denominator? Now remember, guys, this comes from some old math. We don't write the square root in a denominator because for mathematicians that looks really strange. I'm going to see if I can make this guy focus a little better. All right, there we go. So 2 divided by the square root of 20 is a number, okay? That is, it's a regular old number, but we're going to make it look mathematically correct. Now this is not, if you're an engineer, you're just going to take 2 divided by the square root of 20, you're going to get a decimal, you're going to get an approximation, and then you're good to go. But this is not an engineering class, this is a mathematics class. So we need what's called the exact answer. And so to rationalize a denominator, and this is for single term denominators, meaning I only have one chunk in that denominator, I'm going to multiply by a unit of 1. So remember, if you multiply by a unit of 1, you're not changing the value of that equation. So the square root of 20 divided by the square root of 20 is 1. I'm not changing my original problem, I'm just multiplying by 1. So now I just multiply. 2 times the square root of 20 is 2 square roots of 20. Well, the square root of 20 times the square root of 20 is really the square root of 20 times 20, which is 400. Now, how has this helped us? Well, hopefully you see how it's helped us, because the square root of 20 is just, the square root of 400 is just 20. Now, here is where you cannot just leave it like this. because you now are experts at how to simple radical form that 20. Now, I'm not going to go through the whole process, but I will show you this part. So this is 2 times, I'm going to just rewrite 20 as 2 squared times 5 all over 20. Those 2 gets to come out, so I'm left with 2 times the square root of 5 all over 20, which gives me, okay, I can reduce these guys, so I'm left with 4 square roots of 5 over 20, but now I can simplify the 4 and 20, which gives me the square root of 5 over 5. Now, you can check this in your calculator. Please do. Put in the calculator 2 divided by the square root of 20. Okay, you're going to get an answer. Now take the square root of 5 divided by 5. You're going to get an answer. All right, let's try. I want you guys to try part 2. See if you get it. Pause the video here and see if you can figure out what you're working on with this guy. Okay? Try it and see. Pause the video here and see what you get. All right. So on this guy, hopefully you see what you have to multiply by is the square root of 10 and the square root of 10. So when you get this problem, you're going to get 5 square roots of 10 all over 2 times the square root of 100. But 5 square roots of 10, this is just 2 times 10, which is 20. Okay, so you get 5 square roots of 10 over 20, but you can reduce that and you get the square root of 10 over 4. And I will bring this over so you guys can see it. Okay. And so you can see right here, that's what that one looks like. You get the square root of 10 over 4. Okay, well what happens when you get something like 3 and 4? Now 3 and 4 are a little bit different because of the way it's written. In 3 and 4, I have the cube root of 5, and in this guy I have the cube root of 25. And I have to get rid of that cube root of 5. But remember, the whole point of multiplying to rationalize the denominator is to get that radical out of the denominator. So if I have the cube root of 5, I want you don't have to write this part down, I want you to think about it. What's the only way that I can get a 5 to come out of the radical? Only if I'm raising it to the 3rd power. So the cube root and the power cancel out and you're left with a 5. And that's what I need. I need the 5 to be by itself in the denominator. So I want you to think really deeply about this. I have 1 5 here, but I need 3 in order for it to leave the radical. So I'm going to multiply by the cube root of 5 squared. Now if you're like, whoa, wait a minute, Mrs. Taufa, what just happened? Bear with me and you're going to see. Okay, so now I have 7 times the cube root of 5 squared. What happens down here? Well, you have 5 times 5 squared, which is 5 cubed, and now I have the cube root. That's where the magic happens, because now these cancel out, and you're left with 7 cube roots. Well, 5 squared is just 25, so I'm going to write it that way, over 5. Now, I cannot simplify that anymore, so there it is. That is a really nice math problem. Okay, let's look at this guy. So we have to think about 25. Now this is my thinking bubble over here. 25 is really just 5 squared. But again, I have that to the cube power. So what should I multiply by in order to get rid of that square root of 25? Or sorry, the cube root of 25. All right, let's see if you agree with me. I am going to multiply by the cube root of 5. Ooh, let's see what happens. So I'm going to rewrite this. I get 4 over 3 times the cube root of 5 squared times the cube root of 5 and the cube root of 5. Now I chose to write it like that so I could see it a little bit more clearly. Okay, now let's multiply this out. Well, 4 times the cube root of 5 is just 4 times the cube root of 5. Well, here I'm going to have 3 times the cube root of 5 cubed. Oh, look at that. The cube root of 5 cubed actually gets to go away. And now I'm left with 4 times the cube root of 5. Down here, I'm left with 3 times 15, which now gives me 4 times the cube root of 5 all over 15. You guys didn't even catch me on that. That was 3 times 5. There's that 15. Now remember, again, if you're an engineer or you're working with you need an answer, you're just going to plug that into your calculator and you're going to get the decimal representation and boom, there's your answer. But if you're a mathematician, we want the exact answer, and this is the exact way. And it's the pretty way because we don't have that radical in the denominator. Okay, but what happens when you have two-term denominator? What do we do when we have a two-term denominator? Okay, I'm going to bring that down. Well, let's take a look at our two-term denominator. I have 16 divided by 3 plus the square root of 7. Again, that's a number, but we want to write it in a mathematical way so we have no radicals. And here's the trick with a two-term denominator. You're going to multiply by its conjugate pair. Now, you've heard that when we were looking at complex numbers, the i's. Because what happens when you have this same pattern, okay, when you have that same 3 and square root of 7 but opposite signs, when you multiply, you're going to see what happens. Okay, so here is how this is going to look. I'm going to multiply this out. So first, when I multiply the numerator, I get 16 times 3 minus the square root of 7. Okay? Then in my denominator, I get 3 plus the square root of 7 times 3 minus the square root of 7. Now with all of our factoring, hopefully you see I know exactly what's going to happen here. Okay, so let's look at the numerator. 16 times 3 is going to be 48. 16 times the square root of negative 7 is going to be 16 square roots of 7. Now down here, and if you don't believe me, please do this. Okay? Make yourself a box and see what happens. But this is what happens. 3 times 3 is going to give you 9. Now those middle terms, these two guys are going to drop out because you're going to get a 3 square root of 7 and a negative 3 square root of 7. And then you're left with minus square root of 7 times the square root of 7 is that. Okay? Again, if you don't believe me, do your box and see what happens there. Okay, so here I'm going to get 48 minus 16 square roots of 7. And down here, oh, well look at that, the square root of 49 is just 7. Okay, so I get 48 minus 16 square roots of 7 all over 2. Now in my class we talk about, okay, this is an answer, and it's getting really close. You're showing me everything that you need to know, but be careful now. See if you can reduce any more. 48 divided by 2 is 24. 16 divided by 2 is 8. Always check to see if you can do one last thing. So your answer, this is the pretty one, is 24 minus 8 square roots of 7. Okay, I'm going to do one more with you, and then I'm going to have you guys try example 6 on your own. So I look here, I don't like that. Mathematically speaking, this is not a nice way to write your answer. So we're going to multiply by a unit of 1, and we're going to multiply by the conjugate. Because when I multiply by that conjugate, you guys saw what happened here. That denominator factors really nicely. It factors, all of those radicals go away. So here I have 44 times 6 plus the square root of 3. And here I'm going to have 6 minus the square root of 3 times 6 plus the square root of 3. Okay, see if you can find it from here. I want you guys to pause the video right here, and see if you can finish example 6 and see if you can finish example 7. Clearly, I don't know what I was giving you guys, but clearly I wasn't thinking, and I didn't even give you example 8. So I will give you a freebie today. No example 8. So right now, stop the video, finish example 6, and try 7. All right, let's look at your example 6. I'm gonna zoom in and make sure you guys can see that. Okay, and so hopefully you can see that you get 24 plus 4 square roots of 3 divided by 3. Okay, pause the video here and see if that is correct. All right, let's look at number 7. All right, so let's see here, make sure my work is correct. I'm going to multiply by the conjugate of 5 minus the square root of 3. Sorry, that is really hard to read, guys. You should get 10 minus 2 square roots of 3, and down here, 5 minus the square root of 9, which gives us 25 minus 3, which is 22. Now, at this point, you are so close to being done, but the question is can you reduce 10, 2, and 22? So let's remove a 2. I get 5. 2 divided by 2 is 1. And 22 divided by 2 is 11. And there it is, guys. All right, thank you for joining me for day 4. You have one more video to go. Keep up the good work, and we'll see you in the next video.